This is the Insurance Institute for Business and Home Safety's Disaster Discussions podcast, where we explore the intersection of weather and the built environment. Welcome to Disaster Discussions. I'm your host, Rachel Penton-Gauthier. In mid-May, the In-Situ Collaborative Experiment for the collection of hail on the plains, or ICECHIP, departed from Boulder, Colorado for Dodge City, Kansas, as the multi-week, multi-agency scientific storm chasing campaign began operations. IBHS was one of the 19 organizations deploying a range of instruments ahead of incoming hail-producing storms in order to collect data that will help scientists better understand these supercell storms and the characteristics of the hail that falls from them. After more than a month of operations and 19 IOPs, or intensive operation periods, IBHS teams wrapped up our portion of the project where it all began back in Dodge City, Kansas. First up, research project scientist Brenna Meisenzahl reflects on the campaign.
Feels kind of crazy to be wrapping it up. Being out here, your timeline is a bit different. And it's crazy that it's already come to the end, but I've had such a great experience being out here and learning more from industry experts, and doing this type of campaign has actually been an awesome experience.
And how does this compare to IBHS's annual field campaign? What's different about ICECHIP?
So for our annual field campaign, we focus mainly on just ground observations, but ICECHIP was able to incorporate air observations with UAS. We had also our ground observations, but also having mobile radars available to us, and soundings as well. So all of that combined, we're able to kind of see the storm as a whole and how it progresses versus just seeing what's on the ground.
Yeah, normally we have 2 or 3 teams, and we're able to get out there quickly. We have a lot more people, a lot more teams, a lot more vehicles and instruments involved. So how has that gone, and what are your thoughts on that?
I think it's gone pretty well. You're going to have a little bit of hiccups here and there with such a large group of people and so many vehicles. But I will say it's been a lot less on the traveling aspect, which is kind of nice. So we get a break. Typically for the IBHS teams, when we're doing our annual field campaigns, we're doing maybe 8-hour drives or so, and then possibly operating later in the day, which is not typical for us to do that on ICECHIP, which is very nice. So we get kind of that little break in driving.
Is there anything about ICECHIP that has surprised you? It could be really anything.
It surprised me how well we were able to come together as teams and all work on the same objectives, just kind of getting into that rhythm pretty quickly. What's also surprised me is we bring shingle panels out. We have been for the past 2 years or so. And it's been really cool to get the shingle panels that we have out here with us into some really large hail. We've been trying to do that for the past couple of years and haven't been successful, but we've got the F-Wave panels and a metal panel, and it's been really cool to see how the F-Wave actually does in large hail. Like, for example, yesterday we got 3-inch hail in the storm that passed over, and I think that F-Wave has experienced multiple severe hail storms, and it looks still brand spanking new, which is absolutely amazing. It gives us the actual real world results. Yes, we could do the testing at the lab, but this is where we're really going to see how that actually performs. We were cutting some shingles out this morning from that panel to see what it looks like on the back and if it was cracked or anything, and we don't see any signs of it. The sealant has been great. The shingle itself has been great. So it's really cool to see what we're doing in the lab and then bringing it out into the field and kind of helping advance the material science. It's been fantastic. The CMU students have been wonderful to be working with. They're all so ready to get up and get at it. They're ready to help at any point in time. They are ready to lead. It's been absolutely amazing to be working with them. They're all go-getters, and I very much appreciated it. I'm just in general excited to see how this is all going to come together and what these results are going to look like when we have our sounding data and our radar data versus what we're seeing on the ground. Kind of learning more that we're actually seeing more softer hailstones versus hard, which I know we do a lot of hard stone work at the lab. So I'm really interested to see how this is going to play out and how it's going to play out with our shingle ratings and how it's going to further advance what we're doing on the research side. Well, actually, I think my favorite part about ICECHIP is actually the camaraderie and working with everybody. I like being in the larger team has actually made this process so much fun. Even on down days, being able to kind of just relax together and play softball or volleyball, it's been a lot of fun.
Next, instrumentation technician Lucas Faulkner takes a look back.
It's been a grind. We've been out here for a little over a month now. It's gone by quick and slow at the same time. You have fast days, slow days, but this last week has really been a testament to the willpower that we have out here and making sure that we can finish up this last week. And yeah, it's been a lot of fun. We've learned a lot of things, and I'm excited to get back and see what all the data we've collected, what we can do with it. So the lead up to this, it was a lot of testing, a lot of calibrations, a lot of reworks on the instruments and code fixes, hardware fixes, but we got it done. And out here, the instruments have held up very well. We've had a few that we've actually flooded in rivers almost, and they held up fine. So the circuit boards and the wiring, all that we have, we protected it well, and the materials, they've held up well, and I'm excited for it. It's made me happy. It's made my job out here a lot easier with the troubleshooting and all the stuff that happens that you can't foresee. It's always preparing for the unknown. Yeah, yesterday we had a flat tire incident out of nowhere. We had to pull over. Luckily, we were pretty near a gas station, so we whipped it in there. We checked it, realized it wasn't just something that we could use a fix-a-flat with, so we had to jack up the van, change out the tire. And yeah, I think it took about 15 minutes, which it was good. It was a team effort. We had Ian pulling off the lug nuts. I was getting the spare out. We had Brenna was checking all the other tires. Everyone was doing something, so it wasn't just me that made it go by so quick. But it's always just finding stuff that we did not see happening, and then coming up with a solution as quick as possible and as efficiently as possible. So we started in South Carolina at the lab. We drove out to Colorado. I think on that first day we went through 6 or 7 states. Pretty much seen everything east of the Rockies, almost, it seems. Everything has been great. The plains are always great. We made it up to Montana and Wyoming again. Those are beautiful states. I love getting to get up there and see just the wide open country, the big blue skies. We're here finishing off in Dodge City. I almost felt like we started in Dodge City, so it's come full circle here for the Kansas tour. But it's been great. We're about to head back home. I think we're going to head back home on the southern part of the United States. We'll get to see those southeastern states one more time, and then hopefully be in the lab in the next couple days, and then bring this to the end. Thank you to the whole ICECHIP group for allowing us to be out here and participating with us and getting it done. We got a lot of data, a lot of friends made, a lot of colleagues that we'll have for the rest of our lives and get to collaborate on future events and future projects.
Dr. John Allen, Associate Professor of Meteorology at Central Michigan University, highlights the partnership with IBHS and some of the success stories from the project.
Probably one of the most wildly successful field campaigns that has ever occurred. We have had numerous IOPs, a whole range of different hail environments. We've got hail samples that have never been possible before without the instruments and the technology that we've got access to now.
And what were some of your favorite IOPs throughout this journey so far?
It's been a tough one because we've had some absolutely gigantic hail approaching 6 inches and over a pound, all the way down to hail that is almost, you could crush with your hands, so almost like Graupel or something similar. I would say IOP 4, which was around Matador, Texas, was an outstanding case. We got some giant hail on a storm merger. We got lots of stones above 4-inch diameter. That's certainly a very rare data set. Not many teams have ever got that. We damaged a astrometer leg. We've done a lot of things that were unusual there. I think IOP 15, where we had a storm that oriented itself on a boundary, became a transient supercell and produced large accumulations of small hail. Again, probably one of the best documented cases of that. I think pretty impressive was the last 2 IOPs. We went IOP 18 up in Montana. We did 1,100 miles and then got the next storm down in Texas yesterday. I think the Montana case, we had hail up to 3 inches, and then we had 3-inch hail all the way down near Shattuck, Oklahoma. So I think that was a pretty amazing haul by all the teams to do that in a 2-day period. It's a long way to come, but I think was very much worth it.
I think what sticks out to me is that you guys have had just such a huge range of things. Every storm has been so unique. Talk about that aspect.
Well, and I think the important thing for hail is understanding these storms aren't all the same. One thing that we've found that I think is quite remarkable is just how limited the area over which we're seeing some of these largest hailstones. A question you might ask is, well, should we actually be refining in warnings? Maybe these warnings are just too broad for the largest hail sizes. Maybe that's a more tight corridor, similar to the way we do a tornado warning.
And you've been on a lot of field campaigns. How does ICECHIP differ from previous work you've done?
As with all field campaigns, it's a lot of hard work, a lot of instrumentation causing us trouble, a lot of times where you've just got to make the best of what you've got. The problem with the severe thunderstorms is they're not consistent. They're very difficult to predict. Particularly in the last week or two, we've been dealing with mesoscale situations which are incredibly difficult to forecast. So I think ICECHIP has done extremely well in making the best of it. The fully mobile nature of the campaign has meant we've been able to sample these storms in a very impressive way. And I think the fact that we've got probably 12 or more cases where we have excellent distributions of the entire hail swath are going to make a massive impact for science in the future.
And tell me about your role in coordinating the ground teams. What did that entail, and what was that experience like so far?
Initially, it's like air traffic control. You're trying to get teams to go in all the correct locations, reading the motion on the storms. When new storms develop, you've got to be right on top of it, getting teams moving, getting those deployments out ahead. I think it's been a very challenging effort. It's been really cool to work with Dr. Ian Giamanco from IBHS, who has been working with me on that role for the first 12 IOPs. And we did, I think, a great job of sampling these storms and doing some very unusual deployments. Not every deployment is just a straight line. We've been doing 2 deployments on storms. We've done 2 storms in a day even. I think there's a lot of really interesting stuff you learn from trying to coordinate an effort like this, certainly with a number of teams. We've had 14 to 15 ground teams at times. We're trying to coordinate all at once and get them all into the right places and then make sure they're out of the way before the hail gets there. And we've been remarkably successful with that. No ground team has lost a windshield or taken significant hail damage. That is, I think, a pretty impressive effort from both of the ground coordinators ensuring that.
And you're here with your students, so talk about what it's been like to see your students from the beginning to where they are now. I know they've already come a long way.
It's unbelievable. One of the coolest things about ICECHIP and what I really was looking forward to in this project was being able to bring out 10 undergraduate students who have, most of them, never ever seen a storm. A lot of them have never seen a supercell, certainly nothing like of the caliber you see in the Great Plains. And so for them to come out and then get to learn these instruments, learn how to deploy them, some of these students are amazing. They have done amazing work throughout the campaign. They have gone through very stressful situations. Some of the graduate students who are leading the teams, this is their first time leading a team, and they've gone from being, I'm not really sure of this, to the point now where they're confident enough to actually deploy an array ahead of a storm, make critical decisions, and be ready, I think, for more the workforce. I think field projects like this give a fantastic opportunity for students to really develop themselves, to see what they're capable of, and to push their limits.
All right, as we wrap up the last few operation days, where do you think we go with ICECHIP once the field campaign is done?
Well, that's when the data starts to really become a problem, right? We've got a giant data set now. Even just from distrometer data, we have somewhere near 3/4 of a terabyte of distrometer data after IOP 19. That is an enormous amount of data to analyze, to look at the hail distributions. We've got a lot of work to do, I think, to look at compressive stress. We've got more measurements of compressive stress than IBHS has actually been able to obtain in the last decade in one campaign. So that's going to completely shift our fundamental understanding of the strength of hail and its potential to do damage. And I think that the value that this is going to have for the insurance community and for the scientific community is massive. We're going to learn a lot more about hail once we start really digging into this data.
And finally, Dr. Ian Giamanco, IBHS Managing Director of Standards and Data Analytics and Lead Research Meteorologist, reflects on the impact ICECHIP will have on hail science in the years to come.
I don't think it's sunk in yet that our role is finishing up. The project rolls on for a few more days, but this was a dream come true for, I think, a lot of hail scientists. It was 5+ years in the making. And the data that's been collected has just been nothing short of amazing. Everywhere from all the radar data, we've got over 0.5 terabyte of just raw distrometer data alone. We've got shingle panels. We got all the windsons, hailsons. We have potentially record measured thunderstorm updrafts in this data set. This is going to represent a giant leap forward in hail science. So for me personally, I haven't had that sort of emotional moment to think about all the work we've done over the last really 6 weeks. But I think we are looking at a monumental leap forward in hail science. But it will also come with new questions. Things about thunderstorm updrafts, the strength of hail, the ductile compression of hailstones, all of that things, just as science works. We build upon it and we ask new questions. 2 surprises. One is how strong thunderstorm updrafts actually may be and how chaotic they actually are. That's one of the things that the windsondes and hailsondes have showed us. Now, from a hailstone perspective, I think something that was surprising is seeing the amount of ductile compression stones. These are stones that when put under high loads, like 200, 300, 400 pounds of force, don't ever fracture. They just compress and hold their shape. So those are fascinating. We had a few of those in our IBHS database, but we've seen quite a few out here in ICECHIP. And also filling in that strength distribution. We will end up, when you combine the ICECHIP data with our IBHS hailstone database, somewhere close to 10,000 hailstones measured and crushed. That is a very meaningful statistical data set. So I think there could be some surprises in there and how that distribution of strength may change, which also helps us back at the lab refine what we're doing in impact testing at IBHS. Across the ground teams, we had 14 individual vehicles all deploying different types of instruments. So yes, at IBHS, we had our impact distrometers. We had the Purdue and National Severe Storms Laboratory team deploying Parseval distrometers. Those are distrometers that measure raindrop size distributions as well as small hail. Those are also equipped with thermodynamic measurements like temperature, humidity, pressure, and wind data. We also had the tornado pods from the farm group at Alabama Huntsville. Those measure wind speed at about 1 meter height. They also have temperature, humidity, pressure on them as well. And those are just some of the flavors of instruments. And then I'll rewind it back. The old school original hail pad deployed by the Central Michigan teams still has its place, still does great work. And I think we have deployed thousands of hail pads over the 6 weeks of ICECHIP. Don't even know the number off the top of my head. It's too big to count right now. But that's just the spectrum of all the ground instruments that we had going for the ICECHIP project. We worked really closely with the Central Michigan teams. They were responsible for deploying a set of our impact distrometers as well as the hail pads. Our missions were very, very similar, so we worked very closely together. And myself and Dr. John Allen handled the bulk of the ground team coordination efforts during our time in the field. And we were able to really orchestrate that entire symphony of instruments and people to get in front of a wide range and a wide kind of spectrum of hailstorms over this time. So it really was a fun experience for us getting to interact with all the Central Michigan students. They did an absolutely fantastic job, and it was a lot of fun working together with them. IBHS had a wind-driven hail prototype instrument out for ICECHIP. We first tested it last season. We were able to now get several really good deployments of this new instrument that's meant to capture the amount of force and energy a hailstone has when it hits a sphere, which is our instrument, but also the angle it was falling at. That's something our conventional impact distrometers simply can't do. So the wind-driven hail probe is a more precision instrument. It's more high-tech in general, and we were able to get quite a number of really good cases through the ICECHIP project with that prototype instrument. We're hopeful to be able to create more that we can take to the field, maybe 3 or 4 more of these instruments, refine the design, because we still need to understand more about how hailstones are accelerated in the complex thunderstorm straight line wind environment and how they can exceed their theoretical kinetic energies. And that means damage when it hits things like walls, windows, siding, things like that. And we have no testing standards right now for those materials against hail. So a lot of important work to come as we refine this wind-driven hail sensor prototype and start to bring it to the field in the years to come. It's one that's important for entities like IBHS that's helped raise the awareness of the issue and the cost of hailstorms. But we've also helped lead the way in some of the applied research and that resurgence in hail research that we've seen that led up to the ICECHIP project. You may think of these big projects as just being universities and government labs, but the private sector has that role to play, especially us at IBHS, as we look at the application of all this information that comes out of this kind of work and how we, one, can design better testing for our building materials. We can look at how do we incorporate hail into our building codes. And we have all this information to work on to make those weather products that, say, the insurance and risk industry uses every single day with severe weather better and better and better. So, thinking about the last 6 weeks, for me personally, this project was a dream come true. When my wife Tanya and I started the hail research program at IBHS going all the way back to 2010, what we have done in this time period was simply a dream. It was things we thought about, things we wrote down as moonshot ideas to be able to bring all these kind of instrumentation and measurement assets to bear to look at hail in a way that never has been done before. So for me, this has been just an incredibly rewarding experience. It may be the most of my career. Field work to me is something I feel I'm really good at, but it's also one of the things that gives me the most joy and rewarding nature of this kind of work. Going out day after day, going through the grind, making these observations. And it's not just about executing your plan. Everything has to work out for you. The roads have to work out. The storm has to do what you need it to do to get into those roads. And then you need to safely deploy your instruments and go make those measurements you need. So ICECHIP really has been a dream come true. I'm sure I'll digest it a little bit better after I have some rest and take a moment to reflect on what the last 6 weeks have been. But our ICECHIP team from IBHS has been absolutely amazing. The core group of Brenna Meisenzahl, Lucas Faulkner, Jake Sorber, I could not thank you enough for the hard work, as well as the entire ICECHIP IBHS team, and that includes a couple of our members that participated as well. Everyone put in the work, and the project has been a resounding success. So as we look ahead to what could come next for us, I think there's a lot of collaboration opportunities with groups that we worked with on ICECHIP. I look at Central Michigan. We already have our Penn State partnership. There may be more with places like Northern Illinois. But I think from an IBHS perspective, our focus will shift a bit away from understanding the bigger picture of hailstorms, but into product durability to hail. We've had extreme success deploying roofing material panels with our impact distrometers, with high-speed camera systems. We have the wind-driven hail probe. Our work will then turn toward bringing those materials to the field and putting them into real environments. Why wait for the storm to come to you? We're going to take those materials to the storm and go look at this product durability. Because if we look at the picture of growing losses today, this problem is unsustainable at the dollar amounts we see. And we have got to find those materials. We have got to make those tests better to start whittling down that giant exponential growth in hail-related building losses.
This has been Disaster Discussions. Crushing it, ICECHIP takes a giant leap forward in hail science. Thanks for listening to the Disaster Discussions podcast. Join us next month for a new episode. For more on IBHS's ongoing research efforts, visit ibhs.org.